Knowing what kind of graphical options are available can help you decide what will help the client understand what you're trying to teach them better. We'll start with some pretty simple examples. I mean, it's not like the wow factor here is amazing, but I had a client in a multi-dimensional model, right? So predicting y, and there were 20 or 30 different x's. This was one of the x's, and the data clearly followed an upward trend like this, but the slope for that particular data point was downwards like that, which doesn't make any sense at all. And what's happening here is known as Simpson's paradox. It's because that particular x variable was highly collinear with another variable that had a stronger effect. That's not the kind of stuff that's going to make sense to a client. This was a study on businesses and how many communications they had and the connection that they had with other companies. But I said, let's take this picture here and split it up like this. When the other x variable, not the x variable being plotted on the axis, that's x1, but when x2 is low, then you get a slope like this. When x2 is medium, you have the same line, but it gets moved up because of the collinearity issue. And then it gets moved up and moved up. So yes, as this x variable increases, the y is predicted to drop. But if the x variable is higher, that means the other variable is also going to be higher. That's the x2 variable, and that variable is going to cause the y to increase. So overall, we're seeing an increase because of the x2 variable. This picture really helped him understand it a lot better. Another example coming from my master's project, this was looking at mass spectrometry data. I've already gone through how they were doing this and why. They wanted to know where the variability was coming from. Was it from day to day? Was it because of the pre-processing? That's where they put it in the centrifuge and spin it, and they would put it in the freezer and spin it. Or was it run to run? What was causing it so that they weren't getting even results, although they were using the same blood sample over and over? And you can see over here what we found was the day-to-day variability was huge, but the run-to-run variability not so huge. And they were so confused by it. Wait, you're saying when we look across several days, we see lots of variability, but if we look inside each day, there's not much variability. And we tried to explain about variance components and whatever else. I think at some point I mentioned expected mean squares. Shame on me. But we ran out of time, fortunately, and I came back the next week and said, let's pick up the conversation with this picture. If we have a vial and we run it twice, 5 minutes apart from each other, there's going to be a certain amount of variability, and we call that variation due to the machine. But let's take a step back, and let's say that we have 5 vials and we split them, and these ones we do all the pre-processing steps and then run it through the mass spectrometry, and then those ones we do all the pre-processing steps and run it through the mass spectrometry. We're going to get more variability, and that increase in the variability is going to be due to the pre-processing. So we can say there's this much variability total, but this much was just run to run, and this extra amount is because that pre-processing step. And then the big one, which was day-to-day effect, okay, here's all the variability, but we know this much is due to one effect and this much is due to the other effect. So the leftover is the variability we get from running some vials on day 1 and some vials on day 2. And they were like, oh yeah, that totally makes sense. Okay, you can go on. Okay, we just needed a little picture. All right, types of data visualization. Scientific information visual. We're going to go through each of these in turn. Scientific visualization, this is probably what you would think of as just descriptive statistics, okay? Here's the data, drawing a plot of the data, maybe a scatter plot of the data. The idea is to give your intuition a chance to look at it and see what's going on. You're looking for, does it seem straight line or curved, and are the assumptions met, and do I see any outliers that are a problem? If we get a little more fancy, we're looking at the scientific visualization, and there's some overlap because, there's scatter plot that we just barely talked about. But the idea is, can we start to understand and see the kinds of things we want to learn from this data? And all of these plots are probably things you are familiar with, some of these more so than others. And some of these actually belong in the third category, like a word cloud, but we'll get there. It might be worth pausing the video, take a look at these. If there's any graphs that you're like, oh, I don't recognize that, it might be worth looking up. What is that used for? And these come from this website up there, so you can check them out. But here is page 2. These are plots that you probably haven't seen before, and maybe there's a few of them. But some of these look really cool. So the discussion board question is going to be, which of these plots are you like, hey, that's a cool one? I'm not saying you need to use it or should use it on your final project, but if one of these is like, that really has some good wow factor, then maybe you could remember it. And somewhere in the back of your mind, you'll pull it out when you need it. So which of these plots do you think looks interesting? Easy question, okay? You don't have to like justify or whatever. Just say, hey, I like that one. That one looks cool. And yes, I wasted way too much time digging into some of these because I was like, ooh, which to be fair, that's kind of what you want your client to do when they read your report. And they're like, oh, I want to dig into this stuff. And if it looks cool, it can. Here's a data set. We're going to see, I think there's 4 different ways of looking at this data, but they surveyed youth and about how much tobacco are they using, and this has been done for years and years, and they ask them exactly what kinds of things they're looking at. The plot you make might depend on what you're trying to answer or tell the client. This plot, for example, is really only looking at e-cigarettes, and you can see e-cigarettes is climbing up, and other tobacco products are kind of staying the same. Middle school is a little bit of an effect. That's going to be different than if we looked at all the different things, cigars and hookah and bidis. I'm not sure how to pronounce that. Point is, I guess I'm really hoping that's not bidet. But the point is, why is this graph different? Because you can see how these things are less popular than others. And there's a little bit of a year effect. Like any combustible, there was a drop as we go across the years. E-cigarettes has seen a climb, cigars, a little bit of a drop off. But it's all about which type of tobacco method are these kids leaning towards and how is it changing? How come in 2014 hookahs had a big jump? I don't know. Information visualization is very different than the last category because it's not about the statistics. It's about just trying to understand relationships. Here's a word cloud. How do the words all belong? Well, we don't know. The required courses, there's not prediction here. There's not a model here. It's just a pattern we want to understand. The exact same tobacco data we were looking at before. This one's not about how are trends changing over time necessarily. We just want to see which of these cigarettes is being common or popular. Pipe tobacco, not so much. E-cigarettes, a little bit more. And we are splitting male and female, not necessarily trying to compare them because they're not close enough. But are there differences? Well, we can see the trend looks pretty much evenly the same. This particular one was cool because you could change the boxes down here and see something more specific. I want to look at just cigars versus pipes for males. Why? Maybe because the way it's portrayed in movies or some other reason. This one is the same data. It is across the years and split by gender. And we have different lines for all the different types of tobacco. This one's pretty big, but we just kind of want to understand the trend. Here's e-cigarettes, the yellow one jumping up and sort of trailing off as we get to 2016 to 2017. The important message being which plot you choose and what kind of wow factor you go after is going to depend on the message or the information that you're trying to emphasize. It's going to depend on what the client wants to know. One last plot because it's my favorite. If I was to do the discussion board question of show you a wow plot, it'd be this one. And you ought to like pause the video and just spend some time looking at this because it's really cool. It's a big, long, historical story. There's not statistics, which is why it belongs in this category, but here is the French army, and it's huge, coming into Russia, and as they go closer and closer, people start dying, mostly because of the weather, and there's a split off here and a split off there, and as they come and march in, they get all the way up to Moscow, and they've lost a huge number of their army, and they're like, yeah, this was a mistake. So then they turn around and go back, but look at the thermometer here, right? It gets colder, and then colder, and then colder, and you can see the army almost dead. This group that split off here finally joins them to come on back, and they limp home with a tiny fraction of the people they used to have before. There's a massive amount of information in this plot. It's a huge historical story, and I think it's pretty easy to kind of read it and figure out what's going on and understand it, and I'm very impressed with it. So this is my personal contribution to the wow factor.